In the previous video, we already derived the determinants of the real wage and real rental price. So that was almost the end of our theoretical discussion about the Neoclassical model. Okay? And the only thing that we have not yet done is the empirical test, okay, or the evidence, and see if the theory and the evidence are consistent with each other. Okay, but the empirical test is not that easy. Okay, and especially for the variables we want, we probably don't have the data available. Okay, and so that's why here we're going to derive a slightly different way, or alternative way to be able to test the Neoclassical model. Okay, so here that's why we want this alternative way to explain the determination of real factor prices. Okay, now again, let's start with the mathematical derivation, right? And here you find that the real wage equals MPL, marginal product of labor, which equals these. So this part is what we already got from previous discussion. Okay, but what's new here is the a math trick. So what we would do is we multiply this part by L and then divide it by L. Okay, so as you can see here, the L could be cancelled out, so it goes back to this original part, right? But what we want to do here is in the next step, we're gonna open up these brackets, okay, and then you would find this equals to k to the power of alpha and 1 over L to the power of alpha, right? Or you could say it's L to the power of minus alpha, okay, because the L is in the denominator. So that's what we're doing here. Okay, again, 1 minus alpha stays the same, A the same, K to the alpha, L to the minus alpha, because L is the denominator, right? Times L, it's the same as the previous one, and divided by L, right? Now, why we want to do this math trick, just bear with me for 1 minute, and we're gonna see why this is a very smart move. Okay, now here in the numerator we get L to the power of minus alpha and L to the power of 1, right? Here we didn't write it out, but it's power of 1, so we combine these two because they have the same base. It's gonna be 1 minus alpha times A times k to the power of alpha times L to the power of 1 minus alpha divided by L. Here, observation we can make is, look at this part, A times k to the power of alpha times L to the power of 1 minus alpha. This is exactly the production function itself. In other words, this part equals Y, our national income or output, right? So that's why we can simplify this as 1 minus alpha times Y over L. Okay, all right, remember we start with the real wage, so we can rewrite this as real wage equals 1 minus alpha times Y over L, right? Now here we find on the left-hand side of the equation, it's real wage. So empirically, we will be able to get the data about our nominal wage, and we will get the measure of price, like CPI or GDP deflator, right? So with the nominal wage and the CPI, we will be able to figure out the real wage, right? The wage after inflation adjustment. So the left-hand side, we will have the data, okay, to run the empirical test. On the right-hand side, we said alpha is a constant, so we don't have to worry about that. And Y over L, Y, we said empirically it's measured by our GDP, right? L is our labor force or the total population. So every variable in this equation, we will be able to find the data. So this equation derived from the neoclassical model can be empirically tested. Okay, we're gonna see if these two are equal. Okay, and another way to interpret Y over L is the labor productivity. Okay, because Y is the output, L is the units of labor, so Y over L, this ratio represents the units of output each worker or each unit of labor can produce. Okay, so that's how we come up with the economic intuition of this equation. Okay, we're going to see the real wage is determined by labor productivity. In other words, the more productive you are, the more you will be paid. Okay, again, it makes perfect sense. Okay, all right, and so this is for the real wage, right? For the real rental price, we're gonna do similar things. Okay, R over P equals marginal product of labor. Capital, right? Which equals alpha times A times L over K to the power of 1 minus alpha. This is what we already derived from the previous discussion. Okay. Now what we do here is because this time we're changing the units of capital, right? So what we will do is to multiply by K and divide it by K, right? So that the equation will still hold. Okay. And the next thing is we're going to open up these brackets. Okay, so you would find that alpha A stays the same, and K, because here in the previous step it's in the denominator within the brackets, so when we open it, then there would be a minus sign in front of the exponents, so it's going to be minus 1 plus alpha, right? So we move the alpha to the front, then we get K to the power of alpha minus 1. All right, just be a little more careful when we do the math. Okay, it's straightforward, but it might be a little tricky, you know, if you're not that familiar with the exponential function. Okay? And then L to the power of 1 minus alpha. L is in the numerator, so the exponent stays the same, right? Times K, that's the last one here, and divided by K. All right, and then we combine these two parts. Both have K as the base, right? Here it's K to the power of 1, right? So we find that it's K to the power of alpha minus 1 plus 1. Right? And then the minus 1 and plus 1 cancel out. What's left over would be just K to the power of alpha and L to the power of 1 minus alpha. That's this guy here, okay, which stays the same, and divided by K. Here we find A times K to the power of alpha times L to the power of 1 minus alpha is just equal to Y. Okay, so finally we get real rental price equals alpha times capital productivity. Okay, this is a capital productivity because it would be, you know, the number of units of output produced by 1 unit of capital. Okay, so this is a capital productivity. All right, now the next thing we're going to do is to look at the empirical evidence of these. Okay, now here let me go back to and show you this one. What we're going to do is, because we don't know what alpha is, right? And what we would do is we would just, you know, take the change. Okay, so because the real wage and the labor productivity are proportional, so the change or the increase in real wage should be equal to the increase, or should be proportional to the increase or the growth of labor productivity, right? And that's what we're checking here as the first piece of evidence. Okay, so what we're looking at is from 1960 to 2016. Okay, these 57 years. Okay, we find that over this period, the growth rate of labor productivity equals 2%, and the growth rate of the real wage equals 1.8%. Okay, so these two numbers are pretty close. All right, and then here I would ask you to pause the video and make the observation about the other numbers in this table, and then see what kind of takeaways you would have from this table. All right, there are at least two things we could take away. The first one is, as I just said, you find these two growth rates are highly correlated. In other words, when one is high, the other tends to be high. Okay, so for example, from 1960 to 1973, the growth rate of labor productivity is 3%, which is the highest, in these sub-sample periods, right? And the growth rate of the real wage is 2.7%. It's also the highest. Okay, and then from 73 to 95, these both growth rates declined by almost half. Okay, and then from 1995 to 2010, we find both growth rates increased by 1 percentage point approximately. Okay, so here it's 1.1 percentage point, here is 1 percentage point. Okay, and then in recent years, both declined significantly. Okay, so that's why we find they are highly correlated. Okay, so that's one observation. Another observation is we find that the growth rate of the real wage has been falling behind compared to that of labor productivity. In other words, the numbers in the second column is always lower than that in the first column, except for the most recent years, from 2010 to 2016. We find the growth rate of the real wage has, been higher than that of labor productivity. Okay? And now, an extension of this discussion would be, because the increase in real wage has been falling behind, so as you could imagine, the labor's share in total income should decrease over time. That's exactly what we found here. Okay, so previously we said that the labor's share in total income has been stable, persistent. Roughly speaking, that is true. Okay, it fluctuates about 7.74, 0.75. However, if we look at the recent decades, we would be able to find a slight downward trend about the labor share in total income. In other words, over these decades, workers altogether takes less or a little less from the total income. And of course, we said that the capital owners or businessmen take the remaining part, so they take a little more, okay, over these decades. And as you could or probably already realized here, we could talk about income inequality between the rich and the poor. Okay, of course, in this case, the rich tends to be capital owners and the poor tends to be workers. Okay, so here is the Gini coefficient, okay, for the United States. And Gini is the number range between 0 and 1. 0 means absolutely equal, so everybody has the equal size of the pie. 1 means absolutely unequal, so one person in the economy takes all the pie, the entire pie. Okay, as we can see here, in the past few decades, the Gini in the United States rose significantly.